we are going to see the program for reader key and interface display. We are going to use 8086 microprocessor kit and along with the 8279, that is keyboard and display interface. And this is the apparatus required, 8086 kit and 8279 interface. This is the algorithm. We have to initialize the counter, that is how much numbers we are going to, how much digits we are going to display, and set 8279 for 8-digit character display, that is write entry. There are several types of entry here. C for 008 8-bit character display, left entry, and 01 16 8-bit character display for left entry, and for 108 8-bit character display for right entry, and 11 16 8-bit character display for right entry. And this is the letter table. And before that we have to see the algorithm fully. Set 8279 for clearing the display, and write the command to display. Okay, and for a C0 port, we have to connect the C0 port and load the character into the accumulator and display it. Then we have to introduce the delay after that, then repeat from step 1. This is a segment definition. We have to know it first to display a character, because this LED should on corresponding to the letters. See, for A segment we have to on A0, okay, and for B segment to glow, and we have to set A1, and for a C segment to glow we have to set A2, and like this from the from left to right A, B, C, D is assembled, and from E, F, G is assembled from left to right only. This is the display. Okay, it should be on to glow. Okay, and this is the command word for keyboard and display mode. And here there is a letter table I have created for help us, HELPUS. For help, see, there should be, for to draw a H, A and D should not glow. Okay, for that, for A and D should be made as 1, others should be keep it as 0. For display, whole segment will be keep it as 1. Okay, in this way only HELPUS. We can see for U. Okay, for U, see, everything will glow except G and A. Okay, for G and A we have to keep it 1, G, A, and display 1, and so we get the 1C. For 0001 1 and 1101 C. Like this we have to use this 7 segment display, and to display A in a first digit, this is the program. See, move AL comma 00, this is the mode. Okay, that is we are going to display mode, and this should be moved to the C2 port, and clear display CC, and this should be moved to the C2 port. And now we are going to display RAM. So for displaying we have to give the letter 90 to C2 port, and for display A, to maintain A, see, there should be should not be D should glow. Okay, there should not be D glow. So the command word we have to write is 88, and this should be moved to the display side, display port, and we have to blank the rest of the display. So FF should move to the AL, and now we are going to create some gap. So only we are connecting the C0 to AL, and we have to next we have to loop connection, and finally we have to halt the program. This is the program for help us for a lookup table. See, first 8 letters, that is FF, that is no letters should glow. Okay, therefore everything is 1111 1111. So FF is given as input in the lookup table, and 1200 1201 1202 1203, and from 1204 to 1207. Okay, and this is the letter. See, this is a space for help us, and after us here also some space is given, and this is the program. This 1200 is the input for lookup table, and therefore I move this input to source index, and this CX file, we are giving some 15 numbers. See, totally 16 only. So 00 to 15. So only we are giving 15 characters. 0 from 000 to 000F. That is 16 characters we are going to give, and set right entry. Okay, for right entry we will give. We have seen already. See, for right entry we have to give 10. So we are giving 10, and this should be moved to the port C2, and we have to clear the display. Then it is moved to C2. Then write display. Write display means we have to give the command 90 and get the input from source index value. The source index value have the lookup table address. Here we have given the lookup table address, so we can move that value to C0, and we have to create some delay program. This delay subroutine program is here. Then increment source index and loop next, and jump start from top of the program. And after this delay, okay, delay we are giving 0FFF, some greater digit, because it should wait for some time to view for us, and therefore they are giving some delay. This decrement dx and jump to loop 1, then return the program. And this is the program for read a key. And now we can see here there is a keyboard in 8279 interface, and if any key is pressed, it should identify which key is pressed. That's why only this program is used. And here we are moving this 1100 address, because this address only save the output of your program. When 5 key is pressed, it will show the 5 value in this address, and therefore we have to initialize the C2 in AL, that is first in first out status, and we have to test the test whether any key is pressed or not. Then jump off. If it is 0, no key is pressed, it should again check. Then we have to initialize this 8279 port to read, so we have to move this 40, and we have to initialize this port. Now in all the programs, C0 is the important port, and it will display the output, and this C0 port is moved to the AL, and we can get the output in BX. We have address of 1100. Now halt the program. Okay, thus we have seen the programs in read a key and read a key and interface display. Now we can see the hardware program. Thank you. We can see the hardware program using 8086 microprocessor kit, and this 8086 microprocessor kit is a 16-bit microprocessor, and here we are going to see the program. Already I have typed the program for easiness, so we just put U followed by the starting address 1000, then we can view the program. I have saved here. This is the source index value. The source index value is given as 1200 to see the lookup table address we have seen in the program. And now we are moving this 000F initial value and total number of lookup table values, and we are initializing the port now. Move AL comma 10, that is right entry is given as 10, right entry 8-bit character display, and as per this display only I have created this command. And then we have to move this value to C2 port, and next coding is move AL comma CC. Okay, we have to clear the display already which is displaying in the keyboard display, so we have to move this also to out C2 port. And now we have to create the program for delay also, and before that we have to enter the make the character to display in C0 port. Okay, the C0 port program is in the next line. We can see here, and move AL comma 90. This is the C0 port initialization, that is 8279 is initializing using this command only. So 90 is the initializing one. Now we are displaying the character one by one from the lookup table, which is stored in the SI, that is source index 1200 value, 1200 having the input data. Okay, then we have to call delay. Delay is the function which is stored in 1500 address. I have already typed there. Okay, therefore it will call the delay program to display the characters very slowly. Okay, we have to increment the source index one by one until it becomes 0. Then we have to make the loop to display one by one character. Then finally we have to return halt the program and this after this jump value we have to create the return statement also. Okay, return to the main program value. Then we can click we can see the delay program. See, this is the delay program I have already typed. By typing u space 1500 we can see the delay program. See, move dx comma ff. This is the delay program, and we have to decrement dx. Then jump on no 0, we have to move to the line 1504. Then next thing is next line return. Okay, return to the main program. We have to type ret. Okay, then after this we can press enter in the next button in the microprocessor kit, and we can run the program. And we have to see the we can see the lookup table values in SB space 1200. I have already typed. I just show you 12002 1207 we have only FF datas only. After that only help and space followed by space is also FF, and us US after that it should be followed by the space value. So again and again it is FF. Okay, then height 98 E. For E I have given the data input as 68. L for L I have given 7C. P C8 and space followed by space, so FF. Next thing is FF. 120C is FF, and 120D is 1C, that's U, and 120E is 29 S, and followed by the space FF. And now go 1000. This is the keyboard interface 8279. This is the display part and this is the keyboard part. Here only we can see the output. Before executing we can see the display interface. It is connected by RS232 cable. Okay, RS232 cable along with that microprocessor kit. So go 1000, we are executing. It will be viewed as E. See, it will viewed as E, and help us output will be obtained by us. Very happy to see. No, we no need to give only help us, we can see various input. Okay, we can see the program for read a key. Now I have already typed the program, so I just type U space followed by the space 1000. We can view the program, the same kit only, same kit, same RS232 cable, same 8279 interface. This is the program. Move BX, 1100. That is, we are going to see the output only in 1100 value only. Then we have to create input AL, C2. That is initializing the ports. And next line we are testing, okay, whether any key is pressed or not. That is test AL, 07. and jump on 0. If there is any 0, we have to move to the loop again, again to check whether any key is again pressed or not. If there is no key is pressed, then move AL comma 40. This is the port to initialize the display character, okay, using 8279 kit. And next we can see that out C2, okay, out C2 comma AL, that is initializing the ports only. Then we can give the next input line IN AL comma C0, okay. These are all the initialization key, and now we can move that AL value to BX, then halt the program. Now before execution, we have to click next, okay, we have to click next, and we have to write go 1000. Before that I am pressing only 5, key number 5. So after execution we can see go 1000 for execution, then executed. Now we have to click next. We can see the output in SB 1100. We have, if we put enter, then it will show you the key which I pressed. See here, the output display is C5, that is 5 key, fifth key is pressed, so it displayed the output as C5. Now I am resetting the program. Again I am going to press E. I can press E, and we can again execute the program go 1000. We can get the output. Next go SB 1100, we can get the output CE. So we get the output. Thank you.